Another remark related to the tool change. I would like to talk a little bit about the various methods and the different controllers, how to handle that. What we've now done in the example is the easiest way. So you have for example, on the 840D, a T with a number and then an M6. Then you should look up in the controller documentation where this tool number is being stored. That will also needs to happen on the real controller as well. So one of the fundamental principles that we encourage you to use in CSE is to really store such information in the system variable that is also used on the real controller. That makes your life much easier if you try to use subprograms or really more advanced functionality that make use of these variables, and if it then does not contain the correct value, you will have problems then. So that's whenever you have to store something and you would use a global variable, look up in the documentation of the controller if you find the corresponding system variables to store the same information. For the Siemens, like I said, the tool number is stored in this variable $p tool p, and this is the mechanism that we just used before to load it. On the Heidenhain, the mechanism is pretty similar. You will have a tool call also with a number. In this case, it's just stored as a system parameter. If you look that up in the Heidenhain documentation, here's the English one for the TNC 500. It's in the user manual. And under the Q parameter section, you find the system datum read, and here you find an overview of all the system datums that you can use. So, for example, the prepared tool, that one that is being pre-selected with the tool call or tool select actually, and the one that is active will be selected with tool call. You can find that in the system datum 20 number 1. And that's exactly what we do here in the MCF. So in the tool call metacode, we will store this number in the system parameter ID 20 number 1, and then we will use this sysread function from the manual, the system datum read, to read it into a temporary Q variable. That's similar like the R parameters that you know from other controllers. So you stored it in a temporary variable that you can then access from any controller and then do the same tool change as for the Siemens. Another remark for the Siemens controller, it also supports to write T equals and then a string. The question is, the tool number is always a number, so the type of the variable for $p tool p is always integer. The question is, how can the controller store a tool name in an integer? And that's actually not what the controller is doing. The controller is then using this tool data management, and that's an array of variables. So there's actually an array that is called $tctp2, and that contains all the tools known by the controller with the name as a string. And for example, the same or a similar array with also the same index is using or is containing the tool length. And in this array, the index is what can be used with the $p tool p. So $p tool p actually tells the system tool number 3, for example, or tool number 5 in my example. $p, it will search through this whole array, try to locate the tool with the same name, in this case 3D Taster. It will find that, and then $p tool p will contain the array index, so in this case 5. And the CCF files that we've created exactly use this mechanism. So they will create this array, fill it with tool names that you've specified here, and then $p tool p will contain the index, in this case 5. So then the AnyController program will need to get access to the array $tctp2, so that's this one, and the index that we want to access is stored in $p2p. So for the example above, this will contain 5, so we will get access to $tctp2 and index 5, and that will contain 3D Taster, so this means the tool name will be 3D Taster, and then we can generate this tool and locate it in the machine tool view from the ONT and take it from there. So like I said, the CCF file for the 840D includes a mechanism that also handles tool names as strings. Another word for turning machines. In many cases, on turning machines with turrets, they don't use the M6 to actually do the tool change. In this case, it is directly configured that on the T command the turret will rotate, and that the number, the first 2 digits, represent the slot number of the turret, and the second number is the tool correction register that should be used. So that's, for example, for a FANUC, but you find something similar also on Siemens. So in this case, you have to change you have to implement it in that way that in the T command you split this number, and you read out the 08 and handle the 41 differently. So for the tool change, just the first 2 digits are relevant, and that's what you store in also a FANUC system parameter #20 in this case. And then the same way you will get access to this variable and then can use it to rotate the turret, in this case as a B-axis. And in the AnyController section you can use get variable to get the tool number and then actually activate the tool on the turret. So that is also supported by CSE.